Hello everyone and welcome to my channel. In today's video, we're going to be talking about life cycle of a generative AI project. Please, if you could stay until the end of the video because I will break down what a submill is in construction, how much the review process usually costs without using AI, and how little it could cost when AI is used instead. It is very powerful, but at the same time, it is also scary. First thing we're going to be talking about today is the life cycle of generative AI project. Any project in generative AI will go through 4 different steps. Number 1, scope the project. What's scoping the project meaning? Like you have to define the project, the input, what's your goal, what you want. By another way, like just brainstorming and write down exactly what this project is about. And then write it down in a very clean and organized way. And then you take all of this information and you move into building and improving the system. So the system itself will create the prototype based on your scope and the input. And then once the system create the prototype, then it goes into the internal evaluation. And during the internal evaluation stage, the system will test your project and make sure it's accurate, and that's what you want. Then the last step will go into deploy and monitor, and that's when you launch the project. Very important issue here that after you pass the first step, which is the scope, and you move into the building, once you build the project and then you go into internal and you sometime you find out, well, during the test, it's not working as you like. So then you go back into building and modify it, and you go again forward into internal, and then you go into deploy. And once you deploy it and launch it, when the end user starts using it, you find out like still there's some mistake, then you go back into 3 or you go back into 2. So then you keep going around until you reach to the point that your project is good enough. So going forward, when we talk about token, so you know that the tokens are the building blocks of text that AI models process. And this is very important because you're going to be hearing a lot about token in the future. As you're listening to the news these days, they're going to be talking about the cost of token. So some people, they might say, well, I already have monthly plan, or I have subscriptions with whichever model you are using. I just want to clarify something, that there is difference between a monthly plan or subscriptions and something is called API token usage. The API is the application programming interface. So when you have your plan, let's say with the ChatGPT or OpenAI, this subscription plan, this is for you to be subscribed to this model. But as you're working and you work in programming and you work with creating a model, then there is an additional cost. And this cost, that's what we call usage-based billing or API token usage. And it's actually per how many input and how many output, and the model calculate and tell you how much it costs you. So now let's talk about GPT 5.4 model and the pricing of the API or application programming interface. And that's based on April 2026. So if you use GPT 5.4, so input, it's $2.50 per 1 million token. And catch input, it's 0.25 per 1 million token. And here also, I just want to explain the difference between the input and the catch input. The input means new text you send to the model. It's a fresh text. But if you have, if you use the same text again, so the model already seen this text before, that's what we call catch input. And the cost, it's 0.25 per 1 million token. So the way the model calculate the cost, so you have the cost will equal the input token, we already talked about the token in the last slide, times the input rate, plus the output token, and that's a response of the model, times the output rate, and any other storage charges or tools, and this usually very, very minimum. In this slide, we're going to be talking about construction submill. A submill in construction is information the contractor sent to the architect, engineer, or owner for review before buying or installing something on the project. The submill could be shop drawing, product data, material samples such as flooring, ceiling, or finishes, like anything in the project. We usually, as an architect, we usually receive a submill from the general contractor. So now let's talk about the workflow of the submill. How does it work? The general contractor has a product or a sample, let's say flooring, tiles. And the project specification is calling for a particular type of tiles that it should be installed in the bathroom. So the general contractor contact vendors related to the tile and find a specific vendor. This vendor will submit the cost and the spec for this particular tiles. The general contractor will take this product data and the sample, put it in a format, that's what we call it submill, and send it to the architect for approval, because the architect, they provide the specification about this particular tiles on the drawing or in the specification document that is part of the project submill. So usually what happens is the general contractor take this submill and upload it into a software, and most of the general contractor, they use Procore. So once the submill get uploaded into the Procore, and most of the time the submill is just written information or form, and it has some attachment. So the architect will receive a notification that there is a submill. In the architect office, they have a person that once the submill gets submitted by the general contractor, that person will just download the submill, put it in a folder, and this person already created a spreadsheet for the submills, for the project submills. So then that person will add the submill number, the submill name, and then find out if this submill related to architecture, structure, then assign a person to the submills. And then most of the time, we usually, as an architect, we receive about 2 weeks to respond and to close the submill for the general contractor. So also that person will put all of this information into the spreadsheet for the submill receive date and the submill due date to be closed and sent back to the general contractor. And that person will take the submill and the information after that person download the information and put them in a folder. then create an email, and then send the email to the specific group, either architecture, structure, or whoever they're going to be reviewing the submill, and send them all of this information. So once the architect or the structural engineer, whoever is going to review the submill, receive the submill by email, then they start to read the submill and identify what kind of information. Sometimes some submill require some research regarding building code, sometimes regarding a specific bylaw. And so that person will spend some time to review it and then provide the response to the submitter for closing. And most of the time, this response could be either approve or resubmit or reject or any other category, like if the submill is good or it's not good or whatever. Anyhow, so this is what the submill. So then once the reviewer have the first look and the first review, and he's happy, and the reviewer, he or she happy with the response, then they send the response to the head of the department for final review before they issue the response to the general contractor. So in this case, the submittals and the response goes back to the person who actually created, the administration staff who actually created the submittals, and that person will take the submittals and upload it back into Procore, and then close the submittal and go back into the spreadsheet and just write that this submittal was closed on that day, and actually on time, or like 1 day delay or 2 days delay. It's a longer process and it takes a lot of time. And as you can hear from me, that this is a very systematic process, and it could be eliminated if we use AI, because AI could actually receive the submittals, create the spreadsheet by itself, and take the information, review it, and write a very quick description about the submittals, and write proposed response to the submittal, either approve, disapprove, or reject, or whatever the case you're going to be providing to the AI as you are creating the AI program. And then the AI will take all of this information and the proposed submittal and send it to the reviewer with a backup information regarding a specific code review or other document that actually you are storing yourself into your AI system, that the AI will go into that folder and review it by themselves and provide this review and the proposed response. So then the reviewer will look at this information and say, yeah, that makes sense. I agree with this proposed AI response, or let me modify it and send it to the head of the department for final review and approval. And then once it goes and gets approved by the final reviewers, it goes back into the AI for final submittals. So the AI will reissue the response back to the general contractor. So let's see how much is saving on that. So based on what I said, if you use an AI-assisted submittal review workflow, so how much are you saving? For the manual submittals, that's based on my experience. Manual submills, you're going to need about 6.7 hours, and sometimes even more than that. So if you use the AI assistant workflow, you're only going to need 2.25 hours. So I calculated how much the workflow with the AI assistant will cost the company. It will cost about almost like $260 of labor cost. So how much is saving per submills? 4.5 hours. So for each submill, if you use an AI assisted workflow, the company will save about $500. So for a project that require about 200 submill per month, the company could save about $1.2 million if they use AI assisted submill review workflow. And a big project has like 1,000 submills. The saving itself, it could be over $6 million per year. This is huge, guys. This is really huge. That's why at the beginning of the video, I said, it is very powerful, but it is also very scary. So manual submill will take about 6.7 hours and will cost $768 roughly labor cost per submill. AI assistant submills, it will get reduced to 2.25 hours or about $266 per submills. So the saving itself, it's 4.5 hours for each submills, or about $500 labor cost for each submill. So some people, they might say, yes, you explained to us how much is saving we're going to use in human labor if we use an AI assisted submill for each submill, but you did not explain AI usage cost per submill. So on this slide here, I'm calculating the AI usage cost per submill. So the first thing, we're going to calculate the estimated input word. And I calculated based on my experience about 15,000 word. And then you have another thousands regarding like instruction prompting, and another 3,000 regarding prompt, regarding company standard, code reviews, and all of that. So about like 19,000 words. Now we go into step number 2, the estimated output cost, the AI summary, and identifying the issue and propose comments. And I found out that about 2,000 word. So total about 21,000 word, and based on the calculation, so it's 28,000 token. So if we say 28,000 token, so I calculated how much per submill based on the cost that we said in an earlier slide. So the cost for 1,000 submills, it will cost you $56. And in a previous slide, we said the saving for 1,000 submill is $6 million. So $6 million for saving, and here you're talking about $56, very, very minimum. But also you have to remember that there is actually a cost for the person who will be creating this program. That's why it's time for all of us to learn AI, because it is not just a software, it will take over our jobs. If you don't know AI, you're completely gonna be pushed out of the market. I hope that this video was useful. If you found it useful, please subscribe, like the video, and share it with your friend. And we'll talk to you in the next video. And thank you so much for watching.